background? What's your education background? Were you, I don't even know what all your background is.
Well, I can tell you, my degree is in business.
Okay.
And so I'm kind of a business guy. However, I've spent 25 years in the Marine Corps.
Okay.
And as a Marine Corps officer, when I retired at the 25th year, I was a nuclear, biological, chemical warfare specialist.
Okay.
And I was one of the only remaining nuclear weapons assembly officers left in the Marine Corps when I retired. And then I retired and went into the government. And I worked for the Marine Corps as a civilian in the Marine Corps test and evaluation activity. And then I moved over from there to DHS, where I became a GS-15 at DHS, running all the chemical programs for the entire DHS. So
wow.
I had a whole bunch of programs, the various chemical programs, from like the EPA's aspect plane. I had, subway sensors in the subways and stuff like that. So all the chemical programs. And then I went back as a contractor. I became a contractor and went to work for Kalman and Company and supported the Chem-Bio Defense Program for DOD, and had, we went from, just a few early on to eventually having a couple hundred employees that supported the Chem-Bio Defense Program. So we've had a lot of support. And my history with Chem-Bio Defense was pretty well known, and I had the good fortune to bring some good team members together. After I left, primary support to the Chem-Bio Defense Program, I then started supporting the Aspect program. And at some point, really it was in November of 2018, I decided to open Spectral Systems Integration. And the reason I did that was that I saw a difficulty in both payload ability to take a package and get it somewhere and fly it somewhere, a lot of handheld devices, but not many standoff devices. And then the standoff devices that they had were from the ground and from tripods. And so I knew we could probably do something better. And I had the good fortune in all those years to be aware of the state of the art. DOD is the executive agent for all Chem-Bio programs. And so I was able to see the kind of sensors that are making their way into the military, and they were state of the art, no doubt. But I could see the good and the bad. And I also could see that you really needed to have more than one type of sensor to get the broadest area of chemical coverage, right? And that's really where Spectral Systems Integration started looking at. So we were providing support to a fixed-wing aircraft for the EPA and other government agency. But the fixed-wing airplane was big and had a big sensor system. Mm-hmm. Well, you never could have enough of them. It's a one-of-a-kind thing. So we started saying, well, let's watch this drone thing. So early on, Spectral Systems did the typical drone stuff where we were doing real estate, flying, just picture taking with Phantom 4s and stuff. But we were just watching that technology. The technology was really escalating quickly and stuff like that. And what we were looking for is somewhere in the middle between a fixed wing that nobody could afford and the little drones that just wouldn't carry enough capability. There's some drones that have some capability, but none of them with enough.
Right.
Well, then that's about the time, probably, I guess about maybe 6 months ago, 8 months ago, we started talking, and I really started looking online and stuff about agriculture drones, because I knew, or I've heard, that they had more lift capability, right? And so I just started searching, and pretty soon, your company came up as doing a lot of work with these agriculture drones. So I was like, well, let's see what we can do with a payload. Can you fly it or not?
Yeah,
so
I asked about your past, just because I've got a master's in science. I'm a nurse practitioner, and so a lot of the things, like I did some education yesterday on like carbon sequestration, because people were like, as soon as someone starts talking about carbon or anything like this and they're in ag, they just kind of like, oh, this, they don't know what they're talking about. I'm like, well, I do have a degree and I do a fair bit of research, and so it's like we dive deep into this stuff to figure out as much as we can. So I was wondering just your background. Hey guys, so this is Jonathan with Southern Drone Ops. Today is the first of many sit-down interviews and discussions that I plan to have. This has been my favorite project so far, and this is not specifically why I got into the business I am now, but it is one of the many interesting areas that I wanted to be able to offer to help. And I got into this, as we all know, family was in ag, and dad and Renee were crop dusters, so we got into this to really just kind of carry that torch, third gen aerial applicator, with drones and everything. Now I always kind of started out doing turn row crops, but I kind of left that door open to do unique projects. Like when I called the plant board and asked them what all I could do, they, or which license I needed, they said, which one do you want? And I said, well, which ones can I get? So they listed off, the different categories we can have, like aquatics and right-of-way and forest and all those. I said, yeah, I'll take them all. So I took them all. And that way, if a project was presented to me, I wanted to be able to say, yes, we can do that. I just need to figure out how we could do that. And about 8 months ago, Rick contacted me. I've been putting a fair bit out on social media and just said that I was open to unique projects, and that if there was anything that someone would approach me about, more than welcome to send me a message and let's talk. So Rick called me, and he's one of the owners of Spectral Systems Integration. And I always thought I was average intelligence, maybe a little bit above average. And then I met Rick and his crew, and I was like, oh, I'm not smart at all. I don't know. I'm maybe a little below average now. So, but I started talking with them, and they had to do a lot of research and figure things out, because with us it's just been spraying and agriculture and things like that. Well, Rick and his team have developed a sensor that is going to be just phenomenal for detection of particulates in the environment and explosions, just anything biological that can happen, any type of damage to the environment, or oil spills or some sort of chemicals that have gotten out. We're going to be able to monitor these now with the sensors. And so how they got to me was that the sensor was heavy. They needed about 58 pounds to be able to carry, and for most drones that's not feasible. But with our agriculture drones, we can carry up to 120 pounds. So with that, we're able to make an AutoCAD a mount to carry this sensor and to modify our DJI T40 and any subsequent skids that come out, and even other drones, to be able to carry this sensor. So the issue they kind of run into was being able to keep the pilots properly, educated, and enough flight hours, keeping them on standby, and having the available resources. So coming with us, we kind of put our ideas together to say, well, what if we set up a drone program for each city or county, municipality, client, whichever, to train their staff and their employees to use these drones, the agriculture drones, on a daily basis for practical reasons like spraying parks or spraying roadside or medians, aquatics, mosquito abatement, things like that. So we're thinking of like city, projects and things like that, to where if we had that set up, we could let them be using those on a daily basis. And then in the event of a disaster, an emergency, something like that happens, an explosion at a chemical facility, things like that, we're able to take that pilot or whoever is flying that chemical drone for the city or county, whoever, they can immediately transition over into the disaster pilot to man the agriculture drone. But instead, we swap out the payload from spraying to being able to carry Rick's sensor, and they'll be able to monitor for up to 80 different particulates in the air and so many things that Rick is about to tell us about, because I will be able to fly it and carry it, and I can go so deep into it with science, but then Rick is just going to absolutely inform us all about it. But for me, it's just exciting to be able to allow drones to essentially evolve and transition into that, to having multiple uses and dual use cases for the drone, to where daily they can use it to spray, and then just instantly with 4 bolts we can swap out a payload and be able to monitor for a disaster, or monitor for the spread of chemicals or things like that in the air, to hopefully save human lives, or to minimize the damage done to the environment through chemicals like chlorine or ammonia, or just anything that can happen with with an explosion or even a collision. I think everyone's seen the video of the Rick and I were looking at it earlier about the police officer who pulled up on scene, and there was a ammonia truck that had fallen over, or exploded or hit or something anyway, and the driver's collapsed on the ground, and then the police officer gets out not knowing it was ammonia. It filled his lungs and he just fell right over. So that's something we can monitor for with this sensor. And we've had an NDA, now it's released, now we're going to market. So I was really excited to have Rick in today. He's picking up his drone to take to for some politicians to look at, and so I wanted to grab him real quickly, sit him down to explain this to us at length, and this is one of a lot more information we're going to have coming out for it. So Rick, take it away for what all the sensors can do and what you think they need to hear about.
Well, thanks, Jonathan. Yeah, I'm glad to come down here today. We've been down here before, and we've had the luxury of actually flying our payload, and everybody got a little nervous trying to get it up there the first time, but it was
a little windy,
a lot of fun, a little windy and stuff, but we've proven that the drone will get it up there and it will fly it around and stuff, and that's what we were really trying to look for, because we just hadn't found a platform at that time, right? And then it's a big deal. We've came a long way from the shrinking that payload down to something that could be flown in a drone. We hope to be able to shrink it even more. The new composites and stuff that we can make, mounts and stuff out. We've replaced a lot of aluminum and steel in a payload with composites that just 3D printing and all these technologies have come to bear at once.
Your drone original iteration was the VTOL. It's a vertical takeoff and landing drone. And I'll put the video out that Rick had made initially for SSI to advertise this. So, but that's what they'd come to us with, was the VTOL. And obviously with our drones, these are the rotor drones that are bigger for agriculture. So they're wanting to make this payload, smaller and, way less, because in our world, we live off batteries, and so having to land and swap batteries out. So yeah, what he was talking about, the original testing was our first day to fly this thing is 25, 30 mile an hour winds, gust over that. And then the sensor is how much?
Oh, it's 58 pounds.
Or not, cost-wise?
Well.
We want to say that?
It's probably right at about $250,000.
Yeah, so $250,000. I'm flying this thing for the first time in 30 mile an hour winds, and I'm a little nervous. Yeah, I'm flying that thing. We've got the video of it very first taking off, and then the skids are just bouncing back and forth. I was like, oh, I'm going to crash this drone and this sensor on the very first takeoff. But it didn't. It finally stabilized, and as you guys know, the higher we ascended, the more stable it got, and then we had some pretty good flights after that. So
yeah, we did. I was just as nervous, though. I've put a lot into that detector, and I for a while wondered if it was going to be a one of a kind of deal, right? So yeah, but it was great, and we've come even some distance since then. That sensor does do a lot, right? It's not just that it's got great technology in it, but it also has software that is very unique to this kind of a payload, right? It allows us to do this detection in an automated way. So what we have in that payload, 58 pounds, is we really have multiple sensors. We have, brought these different sensors together so that we could get a broader range of chemicals. One sensor may be very good at certain types of detection, like the FTIR is good at gases, and you need to have vapor pressure in order for it to work well. We have a UV visible camera that we found particularly good, and it's proven to be remarkable for chlorine and benzene and stuff like that as well. With all of our sensors, though, it's not, we as we've built them, one of the problems, as an example, with the FTIR was that it's got a small field of view, and it points and stares at the ground in a small way, and it detects the chemical, and it can differentiate between a bunch, but it didn't quantify how much of it is there. And what we've really attacked is the ability to put what we call black bodies, or called calibration black bodies, with this FTIR that allows us now to sweep. And the reason we sweep is because as we come across, each time we look at the black body and recalibrate. And then when we cross to the other side, we hit the hot backlight. So one's hot and one's cold, and we sweep in between it to get a bigger field of view on the ground. But most importantly, now we know the temperature calibrations, and we're able to start to quantify how much agent's there. Well, once you know how much agent's there, you can kind of figure out the duration by the decay of how much agent is there. So that's another big.
So it kind of anticipates where it's.
Well, we can know, is it growing or is it shrinking? Is this problem getting harder or is it
say at the end of an explosion, a chemical factory, something like that, you could anticipate like wind changes and where the chemical could be spreading to, maybe anticipating, some evacuation.
Well, when you know the quantity, if you have to load a model, so you want to load a model to see where it's going to go, where's it going to blow to? When you load a model, you need to add how much there is and the wind directions and stuff like that. Well, if you don't know how much there is, all you know is, well, how big was the train car, and you use a big quantity number.
Right.
Where if we have this detected number, you can feed the model with a very precise number, and then as the model is predicting it and we hit that model, or they hit that target again and detect it again, and it's smaller, we know that the model is going to start to reduce. If it's getting bigger, the model's going to get bigger. So you're actually validating the model as you're getting detections in real time.
And that's live, yeah.
It's a tremendous capability that really isn't out there right now. And then, of course, we still have all the data that's feeding to the ground that people who specialize in models can be, now they have what we would call the holy grail of detected data, that they can fill their model with real, no kidding data from right on top of the target. Right?
And that's going to be like the person that's in charge for the...
well, each jurisdiction will be different. Like the on-scenes coordinator would probably have somebody who's going to monitor, or who would monitor, like say, where's all their detectors and what's their detector string. On-scene commander would also have maybe some modeling capability. He might have some GIS capability where he knows where everything is and its altitudes. And so you start to overlay maps. And so one of the things that we do with our detection, in addition, is we make the map, right? We don't just give a bunch.
This is your team actively that's doing that, involved with it.
Right. It'll come right out of the sensor. It'll come to the ground with a map. And we deliver about 4 different products. One is we have all the raw data, but we analyze it as we go. And as we start to drop to the ground the image of a plume, initially you may only have 2 or 3 detections, but when we got 4 or 5 and you know how much they are, you can start to color code this map in what in real time is going on with this chemical that's out there. And that on-scene coordinator, decision maker, can start to make good decisions. Is the thing still growing? Is it subsiding? And that's a lot of good information. How long is shelter in place going to last? If you know it's dissipating, you got an idea that maybe another couple hours. If it's still getting bigger, and maybe there's a worry that more tanks in a refinery fire are going to blow, and it's going to get worse, then you can make a plan. Right? So
you and your team will be available for these events, like helping process that data and give them that, or is that
Well,
something?
we do reach back, correct. Initially, when we would field one of these types of a sensor, we would provide some scientific reach back. In other words, to help them understand what's coming out of that sensor and learn to use the data. Because a lot of folks, like a client, if we start to sell one of these, is going to say, well, what am I going to do with the data? I don't know if I have people that understand it. Other places will say, oh, I got plenty of people that they're all over this. I got GIS department that can put the maps on, and so every community will be different. But what we do for the first year with the sensor that we would put out is to have this reach back capability that can help them to understand the data, work with them to disseminate it to the places that they want it to go. And then if, say, after a year they decide that, yeah, we got this, we know how to do this, we got our own pilots and we got our own people who analyze the data, thanks a lot. By then we'll be moving on to hopefully another jurisdiction that may need the same kind of capability. But on the other hand, if they say, well, we need that scientific help, we can't afford to have those scientific experts, on staff, for an event that may or may not come very often. So every jurisdiction will be different. Years ago, I was doing, in the Marine Corps, I was still doing some various domestic kind of support with what was then known as, well, still is known, but it's called the Chemical and Biological Incident Response Force for the Marine Corps. And we were going up to different communities to work with them and either teach them something about CBRN or learn something. Well, one of the things that we learned, like when we went up to New York, they have a whole battalion of people who do nothing but research and development in relationship to fires. Very different from some little place maybe out in Arkansas that doesn't have any. They might not even have a whole fire department
out here. Yeah.
You know, so it's a big difference. Well, what we learned when we went up there is that we're going to learn from New York. We're not teaching New York, but then the stuff we learned from New York, we were able to share with other jurisdictions out here when we come. And now today, you look out there, each jurisdiction has a civil support team or more than one, and that kind of integration in the civilian world really came from how the military was doing something, and now you see civil support teams doing their thing. We see something like this capability being able to not just give information to an on-scene commander, decision maker, even the governor or somebody like that who has to give a briefing on what's going on with this situation. His situational awareness will be as good as we can help him to get with visual cameras and sensors. But then additionally, the first responders that are down there, we can maybe help to position them if that's something that they can do. We can maybe tell them how to approach it from the right wind direction. You might want to approach it from upwind towards the downwind, those kind of things. So a lot of the employment and the ability for people to respond quickly can be enhanced by that kind of capability. And that's really what we're doing, is we're trying to bring a capability to the states and locals that maybe just hasn't been available because they couldn't afford their own fixed wing aircraft and million dollar sensors like the federal government, but yet they could still have something at the state and local level that's affordable. They can integrate into their own system.
That's when I talked to you first, that was my thinking was, you're looking at, $250,000 sensor, you're looking at 30,000 in equipment. That's a lot more, palpable or, palatable for, cities or counties, especially if they're kind of, grouping up. Like in Arkansas, I've got the emergency response network, to where if you've got this sensor just in the middle of a few counties or even one per county, and then just like even the county C, like maybe, Jonesboro's kind of the biggest, city around here, to where if they had their own drone program, and then just through some grants or funding, whichever, there was the sensor there that could supply a good amount of area, because, a lot of times, you were telling me some events, are not monitored for days after the event has occurred. And there's so much that's, transpired since then, versus now with this, they'll be able to be on scene, within hours after the event and be monitored quicker than that and monitoring from there. Is that pretty accurate, or?
Yeah, no, I think that's good. Again, unfortunately, all events are different, right? They're all characteristically different. But the common denominator in these events is that the sooner you're there, the better off. Whether it's a fire or anything, the sooner you're there and the sooner they're putting it out, the better off everything's going to be, right? Well, in order to get a capability there, you got to have it within reasonable distance. I say 2 hours is about the longest I'd like to be away from the fire. If I can get there within 2 hours, that we can catch a lot of data. If you let the fire burn out, you let stuff already drift away, then you may or may not have that capability. If you had enough stuff on the ground, you might have everything you need. But the sooner you could employ something like this, the better. And technology has just got to the point where you can. We were talking about, you were showing me a little bit about how to operate this drone of yours, and it's just amazing the capability that these drones have today. They almost fly themselves. I mean, we almost don't want to say it, because then it's like, well, geez, everybody will just buy their own and fly it themselves.
We can automate
but there is a lot of that, right? There's a lot of technology for avoidance and things that are very good. And when let's say we know exactly where the train derailment is, we can just tell the drone, it's going to go there. It's going to the target. And the best thing that can happen for a sensor is to be over the target, right? You got to be over the target to work. Right. And a drone is very efficient at getting where you tell it to go and staying there. And, when we were out there, we were using an example of fighting that 35-mile-an-hour winds out there. But that drone fights itself, I don't know how many times per second, but it tries to stay straight and level in its location. And there's some value to that, right? And
that's what I tell the clients. Their bigger thing with the drones is that, goes back to like trailer. You guys have talked about this a lot. Is people hamstring themselves and get this big, huge, massive monster trailer, and I'm like, that's the whole advantage of our drones is that we're small, we're light, we're mobile, we can get in places where nobody else can. But then when you bring this huge trailer, you kind of hamstring yourself versus the same thing with the drone for this one. We can get in and monitor in areas where nobody else can and set up on the ground. We could be mobile. I mean, the command center and monitoring center, everything can be mobile in the back of a truck or a trailer and move with the event as it's moving. And there's a certain pattern we'll fly that we can import into the controller that's a certain flight plan that we just literally have to import it in and then tap on the screen and it pulls that flight pattern and taps it over an area, and then we just hit evoke and then it takes off and flies that determined flight area, and we can move that flight area as the event changes with it. So I thought that was really interesting. And like you're talking about with the planes and the helicopters, has to be monitored for so long and things like that. But with the drone, we're back on the ground, we need battery, swap outs, but we're on the ground back up in the air in 30 seconds. And so that's a big advantage to having the quick charge and the batteries and being able to monitor that, especially when, 2-3 hours before they might have been spraying a park or something, and then now they're monitoring this massive event, a factory explosion or train derailment or some sort of chemical spill or something like that. It can be any bit of those things to where used to we didn't know where things were spreading or going. Now with this sensor, we'll be able to look at it and go, oh, it's going in this direction. They can get, quicker evacuations. They can, see chemical-wise, what's going to be affected, water sources and things like that. So just think from a environmental standpoint, this is such a massive jump in monitoring and technology that I was really excited to be a part of it. And so my part was pretty easy and quick. They already had this sensor developed and ready. So when they brought it to me, I was like, all right, we're going to go ahead and just pull this together. And so they brought it to me, the sensor, and all we had to do is do AutoCAD, get the mount for it, and develop a plan to be able to teach this and set cities and counties, whichever clients up with a drone program to be able to use this, on a day-to-day basis and then change it for their sensors. So that part is pretty much done. So we went pretty quickly from design and thoughts to implementation and now go to market. And so I just wanted Rick to come in and talk with us today and probably hit a few highlights on the sensor. And I think that's all we may need. Sensor wise, what do you want to tell them? Like, I know it's like 80 I don't know what you want to say.
Well, what happens is, the sensors are all pretty traditional in the sense that, like I explained earlier, that what we call the sweeping FTIR, that's a change to an FTIR in the way that the FTIR does its ability to calibrate itself while in the air and then quantify. That's a big leap. And I talked about taking what might be considered a traditional ultraviolet visible spectrometer and then using it to detect chlorine. And what happens with our software is it's very unique software. We've been working on this software for many, many years. And the software is, my analogy sometimes is to fingerprinting, although my software guys don't like me to really use that analogy. They think it's even much more complex than that. But the fact is, how our technology works is we take the data and then we in essence take a spectrum. We get a spectra from it, and then with this spectra we develop, through artificial intelligence and machine learning, we've developed algorithms that can look at this spectra and ID it from our list of known chemicals. Now, how we do that is in the laboratory, we actually take the chemical and put it into a vacuum or a chemical cell. And then we look at it with our laboratory instruments, and we kind of, I call it get its fingerprint. We kind of learn what this fingerprint is. And then that's called the detection set, if you would. And then when we fly the aircraft outside, we'll look at different backgrounds and we'll do stuff. And then we call that like the training set. That set doesn't have any chemical in it. And then eventually we merge these sets together in a thing we call pattern recognition, and we're able to identify the chemical from what we call its fingerprint. It is more complex than that. But what it does is it's as reliable as a fingerprint, because now we not only have the spectra, but it's automatically looking at 80 chemicals each time. Each time that thing scans, and oh, by the way, it scans at 54 scans a second. Wow. So we're scanning fast as the drone is flying, we're scanning that whole pathway, right? So 50 scans a second, we get that many spectra, and then in our database, we probably have 250,000 spectra, and then we start to compare these spectras and identify if we get hit with a fingerprint. It's kind of like looking for, a bad guy's fingerprint through the fingerprint library. If you get a hit, then you look. Now, what happens with that hit is that means that chemical's there. We do what's called a 6 sigma false alarm rate. It's 1 in a million. We work our software until the algorithms will detect accurately at 1 in a million. And we adjust our what we call boundary areas so that we get to that specification. And then that also gives us what we call a limited detection. And so that's how accurate. Each chemical may have a little bit different detection, a limited detection. We're in the parts per million on some and parts per billion on other chemicals, right? So each of those 80 chemicals has its own limited detection, if you would, on how that chemical is detected. But the interesting thing about our software is that it catches every one of those spectra. So when we're all done, and let's say we didn't detect one of the 80, but we, through quality control, look at every other spectra. And so oftentimes, one event, we might have 1 million spectra. And so we have a method and software that we've learned to help scan it as we go through it, looking at every one of those 1 million spectra to do quality control and see if any agent, now, and by that I mean any one of the 530 different chemicals that we have spectra for. So the automated library does 80, and then our spectroscopists and quality control can do the other 500 plus. That's a lot of chemicals, and it's a lot of data to be able to analyze post-event and really give yourself a pretty good confidence of the level of agent that might have been there. And that's why we go after this 1 in a million, is that we don't want to be wrong. We don't want to say there was something there when there wasn't. Right?
A little liability there. So from here, I know you said you're going to go to the Kansas Capitol and have it. As far as if any potential cities or counties wanted to see this, are we going to be doing demos for them, or what's kind of the plan to get more of this information out for them, or how if they wanted to see, or I know more information, request more information, they can send us that, but if they wanted to see it in person, you have a plan for showing it off, or what do you think?
Well, I don't want to get in the business of trying to run all over the United States,
right,
and doing everybody's demo, because it just costs a little bit to do that.
Right.
However, I think when there's serious people, they're going to want to see it in action in order to do it. So I think we're going to come up with a bunch of materials that people can look at.
And I think even when we do we've got a couple demos coming up. I think we'll do some more more content creation then. So
we have some laboratory test reports and stuff like that, and some field testing that we've done, and we can provide that information if people want to look through it. And once it looks like they're serious, we're more than willing to help them, come to a joint location to demo it where other people are going to demo it. Now, I did say that I have a government contract, right? There's going to be a period of time soon enough where the government's going to do a field test, and people are welcome to. I'm sure the government will let folks come who want to see the demo. Usually they'll have what we call a VIP day, and there'll be a day for press and others to come and look at the capability. So that'll probably be coming. It has to come between now and October, because that the contract will end then. But so there's opportunity to see it for sure, and look at the data and stuff. And we're more than happy to do it. I hate to I don't want to make a plug, but I did work for DHS, and one of my jobs was
Department
grants,
of Homeland Security,
Department of
Department of Human Services.
Yeah,
You kids are fine.
Department of Homeland Security, and doing the chemical programs up there. And we use grants a lot to deal with the states and stuff, and the states are pretty savvy about how to go to DHS for grants for things. And so, I states and locals that do have the ability to try to find the funding for something like this, if it's important enough for them, then they may well be able to do grants through DHS or just their own budgeting. And one of the problems always with this is, man, if to buy a plane and a real expensive sensors was just too much for state and locals. And so we're trying to get this to a place where that might be feasible for them. And then even if they can get it into their own budget loop, that's usually a couple of years. Right. And it seems to me like a long time, but I guess that's not very long in the world of,
and if we can find a use for spraying and for something they could get a return on it immediately. Well, I think just the planes and helicopters, they would just be waiting in the wings to say. No, I agree. With this, they can actually use it on a daily basis and get instant
I like
return.
The idea of that kind of dual purpose use, because you've heard me say I do like the concept that the pilots remain experienced, and I like the idea that they know how to go onto their controller and make a circle and redirect, and that they can load another pattern into there, and because you rely a lot on the pilot getting it in the right place, and then the data flow to the decision maker to give the system. And so there's a communications link that has to take place. And we haven't had the ability to do the link like we do now. I mean, a pilot can change his pattern pretty quickly. His situational awareness is good, and the data that we poke down to the ground, we've never been able to put this amount of volume of data down from the aircraft fast enough for decision makers to really see it and make a difference. Right. So I think we're at a point where the technology is all coming together to allow us to do something good at a price that is probably affordable.
I think it is.
I guess we'll see.
Yeah, that's the biggest thing is I think the affordability of it. I want to drive home with this is the affordability is, we've had, politicians and people look at your larger program before, and it was just the planes and the equipment was millions of dollars. This is, the sensor itself and just the drones themselves, you're around about a $30,000 price point, but they're going to be able to use that on, like I said, a daily basis, or get a return, be able to spray and use it around the city or the counties, daily. And then the pilots are going to stay trained, or, the employees, and they'll be able to use this. And so I think that's the biggest thing to drive home is that, the effects it's going to have on the environment, the price points, the use that it can, right now be used, they're battery powered. So they're going to be able to, save the city for, spraying and doing things right now. So I think that's the biggest thing that people want to look at, and we want people to consider, is that this does so much more than just, the monitor for the adverse event or emergency. It's got a practical daily use, and I just think that that's something that, nowadays, especially at this price point, is just very, really, really hard to find. So I think having Rick in today to explain this to us, we're going to have some more content coming out about, our testing, and we've got a couple more test plots we've got coming in, but past that, we're going to be doing a lot of face-to-face time, let people come see this, see the sensors, see the drones, and then look at the program we have to be able to implement this for the cities so that they can have their own drone spraying program and then have this amazing sensor at their fingertips to be able to minimize effects of things to the environment, things like that. But if you guys got any questions, anything for me or Rick, send us a message or a comment or like this below to see. I've got a lot of questions too. There's a lot of things I still don't know as well. So every time I get to meet with Rick, I get to learn more and more. And Rick has an amazing military career in biochem, and his team that we didn't get to talk much about today, but there's so much experience and knowledge and resources on his team that any cities or counties or politicians that look at it will just see the value that him and his team are going to bring to this, on top of the sensor, on top of the savings from the spraying. I just think that this could be the best thing I think any city or county could implement in. So anyway, guys, give us a like, a follow on all of our socials, YouTube, Facebook, TikTok, all that. And we will hopefully have a lot more content for this to come out. And if you guys got any special questions or you want things answered, just send us a message and we'll try to get it answered for you. Thanks, guys.